Okay, right, we are going to delve into another question. The question, it's a very simple question. It says, a gas in its original state has the following. Pressure is 275 kilopascal. Volume is 0.09 meters cubed. And then the temperature, it's 185 degrees Celsius. Okay, so the gas has its state changed at constant pressure until its temperature becomes 15 degrees Celsius. Find how much heat is transferred from the gas. Okay, now we are going to come back to this question at a much later stage, but not now, because for now the important thing is we need to do the question. Okay, however, the moment you hear things like state changed, constant pressure, temperature becomes, how much heat is transferred from the gas, those words are what we call keywords, simply meaning they have meaning. Meaning is the thing that's going to guide us on how to actually solve the problem. Okay, however, we will deal with the mechanics of the meaning at a much later stage. For now, we need to answer the question. So the first thing that we are going to do here is we are going to say temperature equals 185 degrees Celsius plus 273, and that is going to give us 458 Kelvin. Okay, let's just punch that into the calculator to make sure. 185 plus 273, it's 458, meaning it's correct. Okay, right, so that's our Kelvin. Okay, our volume is equal to 0.09 meter cubed. Okay, and then our pressure is equal to 275 kilopascal. Okay, right. So what are we seeing? We are seeing PVT. We are seeing PVT. So the moment you see PVT now, what does that mean? That means you have MR equals PVT. That's the PVT relationship right there. Okay, so now the thing that we are supposed to do now is the following. We are supposed to find how much heat is transferred from the gas. Now when we say heat transferred from the gas, at some point we structured some notes, and those notes, they actually talk about Q and W. Okay, Q and W, W plus, W minus, Q minus, Q plus, positive Q, negative Q. Okay, right, but we will reflect on that at a later stage. For now, our M is equal to PV over RT. Okay, and that is equal to, if we take P 275 times what is V, 0.09, and then our R, it's given as 0.29, and then our T, we've calculated that to be 458. Okay, for now we're not going to do the dimensional analysis, but dimensional analysis should be done. Okay, and then when we do this, we will find that M is equal to 275 times 0.09, that multiplied by 0. Come now. Okay, right, 0.29 times 458, and that gives us 0.186 kilograms. Okay, now when we have the 0.186 kilograms, is that the answer? Okay, and what's supposed to happen is we are supposed to continue with this calculation from earlier on. Let me just check for those notes. All right. Okay, from earlier on, this is the notes from much earlier on. Okay, we spoke of Joule's law, Okay, and then from Joule's law, what did we notice? When the system loses heat, Q is negative. Okay, Q is heat, W is work done, internal energy, final initial change in energy. And then what we also noticed over here is what? This is Q. Q is what? It's the heat. Heat is described by this equation. Okay, right? So let's take that equation. Let's work with that equation. It says Q is equal to M CP, okay, times T2 minus T1. Okay, now what is going to happen here? What's going to happen is we are now going to substitute M. M is 0.186 CP. It's given as 1.005, okay, and that is multiplied by T2 minus T1. Okay, now when we say T2 T1, what exactly are we referring to now? The thing that we are referring to here now is the gas in its original state has the following attributes. In its original state, the temperature is 185 degrees Celsius. Okay, the gas has its state changed at constant pressure until its temperature becomes 15 degrees Celsius. Simply meaning 15 degrees Celsius, that is the final temperature, minus the initial temperature, which is 185 degrees Celsius. Okay, now mind you, this is in degrees Celsius, it's not in Kelvin, because I'm assuming if you convert it to Kelvin, the difference should be the same. Okay, hence we can leave it in degrees Celsius, or at least that's the hope. Therefore Q is equal to 0.186 times 1.005 times 15 minus 185. Okay, close the bracket. That should give us minus 31.778. In this case, the answer should be joules of sorts. Yeah, it's kilojoules, right? Now, what exactly does this answer mean? What that answer basically means is this is the heat that is being lost by the system, hence the answer is negative. So again, what does the question ask? The question is asking, find out how much heat is transferred from the gas. Yeah, so it's the heat being transferred from the gas. Yes, hence the answer is negative.